In this question, we were asked to come up with 3 different points on the line with these parametric equations, and then we were asked to come up with 2 different vector equations for the line. Well, to come up with 3 different points is fairly straightforward. We just need to pick 3 different parameter values for t, so we can let t be -1, 0, and 1. And then using the parametric expressions given, we would see when t equals -1 that x necessarily is -3, y is 7, and z is 5. So one of the valid points on the line is -3, 7, 5. Letting t be 0 leads to values of -2, 4, and 0. So that's a point on the line. And finally, letting t be 1 leads to this point. So 3 possible points on the line, which obviously has an infinite number of points on it, would be -3, 7, 5, -2, 4, 0, and -1, 1, -5. Now, to come up with 2 different vector equations for the line, what we want to do is think of one of the points as being -2, 4, 0, and a direction vector being 1, -3, -5. The direction vector is the coefficients of the parameter t in the vector equation form. So one of the possible vector equations would be -2, 4, 0 plus t times 1, -3, -5. But similarly, instead of using that, we could multiply this by any scalar multiple, so we might choose -1, and we could use the same position vector of -2, 4, 0, and say that a second direction vector would be -1, 3, 5, making this a slightly different vector equation of the same line.